Welcome back, everyone. This is the last session of the day. It's been a really intense day. We're talking about a lot of technologies, and thank you for staying with us. And I'm delighted to really have Eric join us here. He's joining us from the US. He's, as I'm sure many of you know, probably the best analyst in the field. He's been looking at mini and micro LEDs for a long time. And we've had a lot of discussions today about micro LEDs. And so he's going to be telling us mainly about trends in mini LED technologies, markets, and supply chains. So the stage is yours, Eric. You have 15 minutes. 10 minutes in, I will give you a notice. 13 minutes in, I will give you a notice. So on you go.
Okay, thank you, Kasha, for the introduction and to TechBlick for the opportunity to contribute to this event. Good morning or afternoon, everybody, and thank you for joining these talks on mini LED indeed this time. So maybe before jumping into the topic, a quick word of introduction. I'm sure everybody is familiar with traditional LEDs used in lighting applications and LCD backlight. At the other side of the size spectrum, we have micro LEDs, typically 1 to 50 micron in size, although there are no commonly accepted definitions. And then somewhere in between, you have that gray area of mini LEDs with sizes ranging anywhere from 50 to 200, 300 microns. And here again, there's no commonly accepted definition. It's more the application that defines mini LEDs. So for our purpose today, we consider LCD backlights and narrow pixel pitch direct view LED displays as the key mini LED display applications. So let's start with mini LED LCD backlights and first maybe go through some basics of the different display technologies. Start with OLED, which is a self-emissive display, so every pixel can be switched off completely. And in theory, LED displays can deliver perfect black and infinite contrast. LCDs are very different. Here you have a backlight, which light goes through a matrix of individually controllable liquid crystal valves that either block or let the light go forward toward the viewer. So the image is basically generated by locally occluding the backlight. The problem is that the liquid crystals are not perfect light valves, so even when they're switched off, there's always some light leaking, and dark region tends to be look a little bit grayish, as you see in this image. One way to improve this consists in locally adjusting the intensity of the backlight to match the image content, and this is called full array local dimming. But because the resolution of the LED array is much lower than that of the displays, a halo can be visible around very bright objects that are displayed on a dark background. An obvious way to reduce this halo is to increase the number of zones so that the backlight creates a brightness image closer to the object to be represented. And this is where mini LEDs come into play. Mini LED backlights are just glorified full array local dimming with higher number of zones and LEDs. So when does a regular full array local dimming backlight becomes a mini LED backlight is not clear. Here again, there is no commonly accepted criteria in terms of number of zones or LEDs. At Yole, we usually consider as mini LEDs displays that have at least 1,000 dimming zones, but I'm starting to see some TV brands that are marketing and advertising as mini LEDs products that just have a few hundred zones. One thing is sure, though, is that increasing the number of LEDs reduces the display thickness because you reduce the distance required to spread and homogenize the light from each mini LED chip. And as I already mentioned, increasing the number of zones increases performances and reduce halo. But the hardware is not everything. A good dimming algorithm is also key to the performance. As we'll see here, a well-designed mini LED backlight can deliver contrast and halo performance very close to OLEDs. To quantify this halo, our partner DxOMark uses a bright cross pattern on the dark background and measures a brightness cross section along that red line that you see here. And as you can see on the green curve with an OLED display, the brightness peaks where you intersect the cross and drops rapidly to negligible value in the dark areas, which is what you want. On the edge-lit iPad with no local dimming, because the light leaks uniformly across the full display area, the background is grayish. But with the mini LED iPad with more than 2,500 zones and about 4.5 millimeter each, the performance gets very close to OLED. So here I'd just wanted to show that designing a mini LED backlight goes far beyond just deciding on a number of zones and number of LEDs. I won't get into the details of this slide, but there are multiple architecture possible in terms of driving, assembly substrate,